It's incredibly important to think about how you're going to deal with money within an application before you actually do it. This is because your calculations have to add up when you're dealing with money, because it's important. It's obviously important to a user that you deal with their balance or their shopping basket and come up with the correct answer. The second part to this equation is making sure that the currency is displayed in a way that the user would like. That is, to have a currency symbol. That is, to be displayed in the locale that they're in. So let's think about printing to the screen. You can just print out numbers straight to the console. There'll be nothing surprising there. The number 2 will be printed. But what if we make things a bit more complicated and use fractions? So 0.1 is 1/10 of a dollar or a pound. It's 1/10 of 1. That's fine, and we can expect 0.2 to be 2/10. There's nothing particularly exciting there. It will print 0.2 to the console. However, if we print 0.1 plus 0.2 to the console, we don't get 0.3. We get close to 0.3, but not quite. And there's no special trick here. Both of these are doubles. And assigning them to a constant doesn't make any difference. We're still not going to get what I would term the right answer to be, which is 0.3. So essentially, we have to represent 0.1 as a binary number. And it happens to be that we tend to use exponents and mantisses. This detail doesn't matter, apart from the fact that you can't easily represent 0.1, which is 1/10, in binary, which deals in 1s, 2s, 4s, 8s, and 16s. You lose precision when you do so. So this is about the change of number from a denary number to a binary number. And there's nothing you can easily do to change this if you're storing it as an exponent and mantissa. 0.1 is not easy to store. And the thing is, it's not just that particular number. There are a range of numbers that will be stored and will lose precision. So we can frame this same problem as 10 and 20 cents. And we're going to have exactly the same problem when we add 10 and 20 cents. Of course, I'm not really representing these as 10 and 20 cents. It's $0.1 and $0.2, but the effect is just the same. So when you add the two, in the console we're going to get 0.3, which isn't ideal. And we can assign this to a variable, or a constant rather. And it doesn't make much difference in that the correct result will not quite be correct because we're storing them as a double. So there's an alternative to this. We can store them as decimal. So decimal is stored in a significantly different way for the compiler. And now running the code gives us that reassuring 0.3. But this doesn't look very much like dollars. That's where this number formatter comes into place. So I'm saying I want to format it like a currency, but I also want to use the US formatting. So that's no problem, and then we can print out the result, which is going to be significantly nicer than just displaying 0.3. So we have 0.3 but with the dollar amount in front. So we've printed this, and do excuse the force unwrap, there are ways around that, but this is one way you might choose to store currency to get around this rounding problem. Use decimal rather than double. So the idea here is we're thinking about how we're storing our data types. With currency, this is extremely important because not being able to, say, add up two numbers is a real problem if you have any sort of checkout in your application. Think about it, think about what you're doing, and think about the best type to store your data. In this case, I'd look at decimal.